Hey everybody, this is Mr. Bells here. Sorry, the phone was having a little static going on over there. So this is Geometry's 2-1 lesson. It's on things called conditional statements. So basically, lots of times in math, we'll say stuff like, well, if this is true, then this must be true, or if I do this, maybe like if I clean my room, then I get to go out on Friday night. Okay. In mathematics, we're going to use those things like if x equals 5, then the statement is true. And we're going to build a whole lot of things with these things called conditional statements, and that's what this lesson is about. So here you go. I'm going to give you a little bit of written stuff right now and talk through some of it. So on our conditional statements, we're going to say stuff like this, or a little symbolism like this. It says P arrowhead Q, and this means P implies Q, and P is known as a hypothesis, something we think might happen, and Q is known as a conclusion, what the ending result is for that. Okay, so we're going to have several things, and again, this would be, let's try this one. If I clean my room, then I can go out Friday night. Okay, so in this case, the if part is kind of like the P. So if I clean my room, that's my hypothesis. So if that actually happens, then so again, this part right here is the P. Then the conclusion is what happens right there. Okay? So then there are 3 different things that we're going to talk about with a conditional statement. We're going to talk about its converse. We're going to talk about something called its inverse. And we're going to talk about, this is a big weird word, it's contrapositive. Contrapositive. Okay? And I'm going to give you a little notation for it first. So the converse would be Q implies P. If I go out Friday night, then I cleaned my room. And again, we're not saying whether these things are true or false. We're just saying that that's what the converse is of it. The inverse looks like this. And these little squiggles here, these little symbols for the squiggle, negate it. So like saying the negative of it. If I don't clean my room, then I don't go out on Friday night. Okay? And then the contrapositive simply switches the inverse. So squiggle Q implies squiggle P. Okay, so first one in more detail here. I'll write it out for you. The converse of the statement. Change the view up a little bit. There we go. Converse would look like this. If I go out Friday night, then I cleaned my room. Good deal. That's converse. Inverse with the same statement. Inverse. If I don't clean my room, then I don't go out Friday night. Okay, so that's the inverse, and then the last one, the contrapositive. Remember, we said that the contrapositive is just a switching of the inverse. So and you could probably even write it yourself now, right? You've heard me say it. If I don't go out Friday night, then I don't clean my room, or didn't clean my room, whichever way you want to put it on there. Okay, so on each one of those statements right now, you can see the fact that they're similar, right? We've got room in it, and we've got Friday night in it. Again, the first one, just called a conditional statement. Conditional statement, putting a condition on something. And that's the original conditional statement. It has a hypothesis and a conclusion. Okay? And then there's a converse, which simply switches the two hypotheses and conclusions. An inverse, which negates the original one. And a contrapositive, which switches the negation of the first one. Okay? So that's what we look like right now. And then we talk about, with all of these statements, mathematically speaking, whether or not they are true or false. And here's the deal with this. There are things that are called equivalent statements. Equivalent statements. And equivalent statements are ones that have the same truth value. So here we go. The original statement, I'm not saying whether or not it's true or false for your situation, but we're going to say right now for this situation that it is true. Okay? That your parents said, if you clean your room, then you do get to go out. So that's true. Okay? Now, the second statement says, if I go out Friday night, then I clean my room. Well, I don't know that I can guarantee that. That actually might be false. I know that I get to go out if I clean my room on Friday night, but there's nothing that says that that I couldn't go out on Friday night for some other reason. Okay, so maybe there's like 6 different things that could have happened, or whatever. So I can't guarantee that this second statement is false. I might have gone out without cleaning my room, but I know that if I do it, clean it, I get to go out. Okay, so the first and the fourth are always going to be equivalent statements, and the second and the third are always going to be equivalent statements. So a converse and an inverse will always hold the same truth value, and a conditional statement and its contrapositive will always hold the same truth value. Okay, so those are our big things right now for the beginning part of this stuff. And then we'll have all kinds of statements dealing with specific lines and postulates in this. And before I go there, I want to write something. This is true. So it's something called a biconditional statement. And we'll end up talking about these a lot in this class, a biconditional statement. Biconditional statement is something where the conditional is true and its converse is also true. Let me give you an example of something. If 2 lines happen to be what we call perpendicular, if 2 lines are perpendicular, then it forms 4 right angles. Okay? So if 2 lines are perpendicular, then it forms 4 right angles. Well, the answer to that is true. That is true. And if 2 lines form 4 right angles, then they must be perpendicular. Well, that's also true. So the conditional statement in the converse is true, means that now we technically have a definition. Okay, it's not just a one-way directional situation. It doesn't matter that if one statement is true, then the other one is also true. So that's what we call a biconditional. And in this class, we're going to discuss biconditionals to be definitions, and definitions are going to be a huge part of what's going on, okay? And in this class, we're also going to deal with these things. So let me show you. Hopefully you're good with what I just said. I'm going to straighten that out a little bit. So we're also going to have some things called truth tables in this unit. Again, this is 2.1. And these things right here, okay? So the truth value of a statement is either true or it's false. You can determine the conditions under which the conditional statement is true by using a truth table. The truth table below shows the truth values for the hypothesis P and conclusion Q. So I've got P and Q, and we're going to assume that P implies Q. If P is true and Q is true, if both statements are true, then P implies Q is true. If P is true and Q is false, then the conditional statement is considered false. So like it says, if I do my homework, then pigs fly. Well, true could do my homework, but the conclusion, pigs fly, it's not true. That's always false. So that means the conditional statement is false. If my original conditional statement is false, but my conclusion is a true statement, then it's considered true. And if both my original statement and the conclusion are both lies, then the statement P implies Q actually is true. Okay? So those are examples of truth tables. In your textbook, you can look at it in converses and inverses, and they'll tell you exactly what it is. You can see contrapositives are squiggle P's and squiggle Q's, and squiggle Q's and squiggle P's when we do the negations of them. Okay? And so just to make sure we're clear on this, if a statement is originally true, then its negation of that statement must be false. Just like you can see here, if this is a true and a false, and negation of that true statement is also true, and the negation of the false statement is also false, the end result is false. So you can look at any of those ones and go through it. Okay? So some of the basic questions from the thing look like this. So I'll give you one of these ones. You are in a band and you play the drums. So if you are in a band, then you play the drums. Let's assume that that's a true statement. If you're in a band, then you play the drums. Does that also mean that if you play the drums, then you're in a band? And that answer is, of course, false. I have actually played the drums on a little rock band game that we have on, oh gosh, what is it? PlayStation 2? Yeah, PlayStation 2. And we do not have any band that I'm a part of, in fact. I don't play the drums very well, but I still play the drums sometimes. Play the air drums too. So that's one of those things, right? The negation of a statement. So the lake is cold. You would simply write the lake is not cold. The ball is not pink. The negation of a not statement is the ball is pink. So negating something that's already negative, of course, just like anything, cancels it out. Okay? Something like over here, this says write P implies Q, Q implies P, the inverse of both those things. Then decide whether statements are true or false. Okay? So let's go 24. Let P be its Valentine's Day and let Q be its February. If today is Valentine's Day, then it's February. That's true, right? If it is Valentine's Day. Now let's do the converse. So we flip them, right? So the converse is if today is a day in February, then it must be Valentine's Day. Well, that of course is false because there are either 27 or 28 days in February that aren't Valentine's Day. So we can't guarantee it that way. And just like if the original conditional statement was true, then we know the contrapositive is true, right? If it's not a day in February, then it's not Valentine's Day, which is obviously true. And we know that since the converse was false, then the inverse is also false. And the inverse says that if it's not Valentine's Day, then it's not February. And that makes sense, too. Okay, so again, hoping this was beneficial to you. Please make sure you pay attention to each one of those words and what they mean and how we change statements with those. Good deal. Talk to you later.